So no problem. Hello and welcome to our YouTube channel. My name is Clinton P. Kui, and today we are going to continue our series on the Math 304 section 1, 2, and 3 maiden practice questions. So today we are going to do question number 8, and it will come as no surprise when you go back and see from question number 1 to question number 7, because we provided a step-by-step solution. So if you haven't seen those videos, I encourage you to check out our channel. So question number 8 says, we should find the differential equation of the family of hyperbolas. So find the differential equation of the family of hyperbolas with asymptotes as the line x plus y equals 1 and x minus y equals 1. So what family of hyperbola have these equations as their asymptotes? So the first thing we're going to do is to draw a picture of what we're talking about. So these two equations are the equations of the asymptotes. So we draw something like this. We say this is the hyperbola, and we know the asymptotes of the hyperbola is a line. So there are two asymptotes. A line that approaches the hyperbola but does not touch the hyperbola is called the asymptotes of the hyperbola. So this will be a little bit close to this. This will also be a little bit close to this. So the equation of this line, this one, is x plus y equals 1, and the equation of this one is x minus y equal to 1. So that's the general idea. You are given the equation of the asymptotes of the hyperbola, and you are told to find the differential equation of that family of hyperbola. So the first thing we do is we want to find the point of intersection of these two asymptotes. This is 1 and this is 1. So the point of intersection will give us the center of the hyperbola. So we take x plus y equal to 1, and we take x minus y equal to 1. To find the point of intersection, we solve the two equations simultaneously. Once we solve the two equations, the result we get, meaning the solution to the simultaneous equation, will be the intersection of these two lines. And the intersection will give us the center of the hyperbola. So if you have seen the graph of a hyperbola, you will realize that if the center is at the origin, then the graph of the hyperbola, especially when it lies on the x-axis, will be like this. So you have the center at the origin and you have the graph like this. So if the hyperbola is on the y-axis, the center is at the origin, you have the graph going up. So that's the general idea behind this question. So let's find the point of intersection of these two lines. We add x plus x, that's 2x, and then y minus y, that's 0, so equal 1 plus 1, that's 2. If we solve for x, we divide each term by 2, so x will be 1. So x is equal to 1 is the x coordinate of the center. We move on to find the y coordinate by taking any one of these two equations. So we say x plus y equal 1. So we replace x with 1, 1 plus y equal 1. To solve for y, we send this 1 across, so y is 0. So x equal 1, y equals 0 is the center of this hyperbola. Now, once we know the center, we can proceed to write the equation of hyperbola. So the equation of hyperbola is x minus h all squared plus y minus k all squared. So this is minus, this is divided by a squared, and this is divided by b squared, and everything should be equal to 1. So it's x minus h all squared over a squared minus y minus k all squared over b squared equal 1. But remember, a and b are the vertices. So this a is the vertex on the horizontal axis, and this v is the vertex on the vertical axis. So a and b, in most questions, they are different. They have different values, but specifically for this question, a and b have the same value. So whatever value goes for a is the same value that goes for b. And we can continue the solution to the question right up there. So after we have this equation, we're just going to replace x is 1, so we're going to have x minus 1 all square over a square minus y is 0, y minus 0 all square over a square. So replace b square with a square, everything should be equal to 1. Now, once we have that, so from here we'll go here, Once we have that, we can multiply the entire equation by a square. So we have a square multiplied by x minus 1 all square over a square minus this is y square over a square, and everything should be equal to 1. So multiply a square by each term. So what do we have? A square times this and this are going to cancel out. I'll have x minus 1 all square minus, this also cancel out, y square equals to a square times 1, that's a square. I can differentiate, each term to solve the differential equation or to solve the differential equation that I need. So I differentiate x minus 1 all square, I'll have 2 times x minus 1 raised to the power of 1 because I subtract 1 from these two, and multiply by the derivative of the expression in. So the derivative of x minus 1 is just 1 minus the derivative of y square is 2y y prime, and the derivative of a square is 0. So I have 2 times x minus 1 minus 2y y prime. The differential equation, or in order to get a differential equation, I can divide this by 2, divide this by 2, and divide this by 2. So I'm going to have x minus 1. So x minus 1 minus, then these are also going to cancel out, y prime equal to 0. So I can send y prime across. I'm going to have x minus 1 is equals to y prime. So ladies and gentlemen, this is the differential equation of the family of hyperbolas whose asymptotes are x plus y equal 1 and x minus y equal 1, as you see on the board there. And thank you very much for watching.